Hey guys, welcome to the beginning of the last chapter in Algebra 1. The last chapter that we're going to do is over radicals. So what I need you to do in your journal, the first part is I want you to write down this list, 1 squared all the way to 15 squared, going down your journal. 1 squared equals what? 2 squared equals what? So I'd have 1 squared equals 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I want you to continue that list all the way down to 15 squared. Okay, so press pause, go ahead and do that, and then press play when you're ready. Okay, so I've got my list made up all the way on the left-hand side here from 1 squared to 12 squared. You should have 13, 14, and 15. But that's going to be great reference for when we're simplifying these radicals. So what I mean by simplifying is we know that we can type the square root of 8 into our calculator and we get a decimal. We've done that before. We can round that decimal to the hundredths place, 2 decimal places, but that is not very accurate, okay? And it's hard to work with decimals. Decimals, you have to round and all that, and we don't want to have to do that when we need things precise. So what we're going to go over today is how we can take a square root, such as the square root of 8, and simplify that so that our answer still has a square root, but it is reduced, if you can think of it like that. So what I do is I take the square root of 8, and I look along my column that I just made here, and I see which one of these, what are these called? These are called perfect squares, is a factor of 8. So I know that 4 right here is a factor of 8. So I can rewrite 8 as being 4 times 2, right? 4 times 2 is the same thing as 8. I haven't changed the problem at all. I can take this and I can rewrite it as the square root of 4 times the square root of 2. I still haven't changed anything. The 4 is still under a square root symbol. The 2 is still under the square root symbol. They're just under their own square root symbol. Now I know that the square root of 4 is 2. The square root of 2 is a decimal, and so I don't want that. We don't want any decimals, so you leave that square root of 2, and that is your answer. You have just simplified the square root of 8 to be 2 square roots of 2, or 2 radical 2 is another way of saying it. Okay, let's look at the next one, square root of 45. How can we simplify that? We look at our long list of perfect squares. We can only pick numbers that are perfect squares, okay? So 15 times 3 is 45, but 15 is not a perfect square, 3 is not a perfect square, so that doesn't do us any good in simplifying, okay? So I look along my list and I see the square root of 45 can easily be 9 times 5. 9 is the biggest perfect square that goes into 45. So again, I can simplify that to the square root of 9 times the square root of 5. How do I simplify that further? Well, 9 is a perfect square. So I'm going to circle that. It's a perfect square, and I'm going to rewrite this as 3 times the square root of 5. The square root of 5 is a decimal. I don't want decimals, so I leave it. Let's look at the next one, square root of 50. I want you to think this one to yourself. What is a factor of 50 that's a perfect square? That's going to be 25 times 2. Now, if you need to keep writing this as the square root of 25 times the square root of 2, you're welcome to, or you cannot do that step, and what you could do is you can circle all your perfect squares, and then you know that you need to take the square root of that. So the square root of 25 is 5. That goes outside my square root symbol because it's no longer in a square root because I took the square root. So I'm done with that. So I have 5 square roots of 2 as my answer. Okay? Now, let's do just a couple more here. Let's do the square root of 98. What's the largest perfect square that goes into 98? If there are multiple perfect squares that is a factor of a given number, you always want to pick the largest one, okay? Your answer is not going to be fully simplified until you have picked the largest perfect square. So what's the largest perfect square that goes into 98? That would be 49. That's 49 times 2. 49 is my perfect square. I'm going to circle that. I'm going to take the square root of 49 to get 7, and I'm going to leave my 2 in the square root symbol. When I do the square root of 48, I know that that one, the largest perfect square is 16. 16 times 3. I'm going to circle my perfect square. The square root of 16 is 4, so I take it outside my square root symbol, and there's my answer. Square root of 80 being squared. We've done something like this before. We know that the square root and the square are inverses of each other. They undo each other. So this square is canceled by this square root. So what was the answer to that problem that was just on the board? It's just 80. Okay, so let's keep on moving. Here we have a square root symbol with a fraction, some division. So the way that I handle this is I break this up just like we did the multiplication, and I'm going to write this problem with each number under its own square root symbol, just like that. Now I just simplify it, go from there. The square root of 36, that's a perfect square. That gives me 6. The square root of 100, well, that's also a perfect square, so I get 10. Should I leave my answer like that? Nope, I should reduce it to get 3/5. There's your answer. All right, the next one. Again, it's one fraction under one square root that I'm going to rewrite as one fraction with each number in its own square root. Okay? Now, square root of 5. That is not a perfect square, but it cannot be simplified anymore because there's no numbers that multiply to give us 5 that are a perfect square. 9 is a perfect square, though, so this can simplify too. I have to leave my square root of 5 alone on the top and put a 3 on the bottom, not in the square root symbol because the square root of 9 is 3. All right, let's look at the last one here. I'm going to rewrite this as what? Square root of 12 over square root of 27. Okay, now, the square root of 12 I know is the same thing as 4 times 3, right? 4 is my perfect square, so that simplifies to 2 square roots of 3. Now let's look at the square root of 27. The square root of 27 breaks up to what? What's the perfect square that multiplies to give us 27? That's 9 times 3. Well, 9's my perfect square, so I circle that, and I get 3 square roots of 3. Okay, now, I need to keep simplifying this until I can't simplify it anymore. The square root of 3 and the square root of 3 cancel with each other. Square root of 3 divided by square root of 3 is 1. So my answer to this problem is 2/3. All right, here I have some variables now. What I can do is I can take this problem and I can break it up into the square root of x to the 5th times the square root of y squared. Okay, now the square root of y squared, you guys should know that one. The square and the square root cancel each other. So that leaves us just with y. So that's what we want to try and get at with our x to the 5th. So you want to ask yourself, how can you rewrite x to the 5th so that you have x squareds? Because squares and square roots undo each other. That's our goal. So I can, see if you agree with this, I can rewrite x to the 5th as x squared times x. How can I do that? Because they have the same base, you add exponents. 2 plus 2 plus 1 is 5. So I haven't changed my problem at all. Just rewrote it so that it looks a little different. Now, I'm going to circle all my perfect squares. Anything that has a squared is a perfect square. So, I take the square root of this x squared, and that is x. I take the square root of this x squared, that's x. I can't do anything with this guy right here because he's not a perfect square, so he has to stay. Okay, now I'm going to simplify this a little bit further. If I have x times x right here, that gives me x squared. Now I also had this y. We can't forget about it. It was not in a square root symbol, so it's going to be written right next to the x squared. And then I have the square root of x all alone right out there. And that is our answer. Okay, so let's try the next one. I'm rewriting all of these things into as many squareds as I can. A to the 8th, that would give me a squared, a squared, a squared, a squared. I have 2, 4, 6, 8. B to the b cubed, that's a b squared and a b. C to the 10th, how many c squareds would I have? I would have 5 of them. Now I'm going to go through and simplify this. I'm going to circle all my perfect squares. Okay, so circle everything that is a perfect square. I can't circle that b, but everything else is a squared, so I get to circle that. Now I want you to count how many a squareds did you circle? I circled 4 a squareds, so that would be a to the 4th. How many b squareds did you circle? 1. How many c squareds? 5. And then what was left inside your square root symbol? We had a b left over, and that was it. That was the only thing that we could not take the square root of. Okay, let's keep trying these.